Advanced AWS interview questions. 1. Explain the CAP theorem and how it relates to AWS services like DynamoDB. CAP theorem states that a distributed system can only provide two out of the following three guarantees simultaneously. Consistency. Every read receives the most recent write. Availability. Every request receives a response either successful or failure. Partition tolerance. The system continues to operate despite an arbitrary number of messages being dropped or delayed by the network. In AWS DynamoDB, you can choose between eventual consistency and strong consistency for reads. Eventually consistent reads provide higher availability and partition tolerance. It means data may not reflect the most recent write, but consistency is eventually achieved. Strongly consistent reads provide consistency but might reduce availability in case of network partitions. DynamoDB gives developers the flexibility to select the consistency model based on their application's needs. 2. What are the key differences between Amazon RDS and DynamoDB? Feature Amazon RDS. DynamoDB type relational database service. SQL no SQL. Database service. Schema requires predefined schema. Schema less flexible scaling. Vertical scaling. Limited horizontal. Horizontal scaling. Auto-scaling supported backup. Automated backups and manual snapshots. Point-in-time recovery on-demand backups. Indexes supports primary, foreign keys, and indexing supports primary key, partition key, and indexes. Use cases. Traditional applications with relational data. High throughput, low latency, unstructured data. Consistency, immediate consistency. ACID transactions eventual or strong consistency. Cost model pay for the instance size and storage. Pay for throughput red dart write units. 3. How would you architect a highly available, scalable application using AWS? To architect a highly available and scalable application using AWS, follow these principles. Use multiple availability zones. Distribute resources, EC2, RDS, etc., across multiple AZs for redundancy. Auto-scaling groups. Use auto-scaling to adjust the number of EC2 instances based on traffic demand. Elastic load balancing, ELB. Use ELB to distribute incoming traffic across multiple instances in different AZs for fault tolerance. Stateless applications. Keep your application servers stateless. Store session data in Elasticache, Redis/Memcached, or DynamoDB. Use managed services. Use AWS services like Lambda, serverless functions, and DynamoDB, NoSQL, for seamless scaling and fault tolerance. 6. Database scaling. For relational databases, use RDS with multi-AZ for high availability. Use RED replicas to offload RED traffic and sharding for large datasets. 7. Content delivery. Use Amazon CloudFront as a CDN to cache and distribute content globally for low latency and high availability. 8. Security. Secure your resources using IAM roles, VPC with public-to-private subnets, security groups, and network ACLs. Use AWS Shield for DDoS protection. 9. Monitoring and logging. Monitor performance and availability using CloudWatch. Enable CloudTrail for logging API activity and VPC flow logs for network traffic analysis. 10. Disaster recovery. Implement backup strategies using S3 and Amazon Glacier for long-term archiving. Plan for cross-region replication and failover scenarios. 4. Explain the different consistency models in DynamoDB. DynamoDB supports two consistency models for read operations. Eventually consistent reads, default option for DynamoDB reads. DynamoDB ensures that copies of data across all locations eventually become consistent, but reads may reflect stale data temporarily. Offers higher availability and lower latency. Strongly consistent reads. You can opt for this when you need up-to-date data on every read request. Ensures that the most recent write is always reflected in a read at the cost of higher latency. Provides lower availability compared to eventually consistent reads, especially in the event of a network partition. 5. How does S3 ensure data durability? Amazon S3 is designed for 99.999999999% 11 nines durability, by storing data redundantly across multiple devices in multiple facilities within an AWS region. Here's how S3 ensures durability. Replication within the region. Data is stored in multiple AZs, ensuring resilience against the loss of a data center. Data integrity. S3 performs regular checksums to ensure data integrity. When data corruption is detected, it is automatically repaired using redundant copies. Versioning. S3 allows for versioning, so previous versions of an object are retained. This protects against accidental deletion or overwrite. Cross-region replication, CRR. CRR can be configured to replicate objects to another AWS region for further protection against regional disasters. 6. What are some best practices for securing a multi-account AWS environment? Use AWS organizations. Manage multiple AWS accounts under a central organization, applying centralized policies and controls. 2. Enable AWS Control Tower. AWS Control Tower can be used to enforce governance and best practices for a multi-account setup. 3. Least privilege principle. Define IAM roles and policies with the least privilege, ensuring that users, groups, and services have only the necessary permissions. 4. Use service control policies, SCPs. Apply SCPs at the organization or organizational unit OU level to restrict certain actions across all accounts. Use AWS Single Sign-On, SSO Centralized Access Management for AWS accounts through SSO integrating with external identity providers, VPC security. Use VPCs, security groups, and network ACLs to isolate different environments, production, staging, dev, and control network traffic. Logging and monitoring. Enable CloudTrail to log API calls across all accounts. Centralize logs using AWS CloudWatch logs or AWS S3, and implement security monitoring tools like Amazon GuardDuty. Cross-account roles. Use cross-account roles instead of long-term credentials for accessing other accounts securely. 7. How do you architect for disaster recovery in AWS? Disaster recovery, DR strategies on AWS depend on your RTO, recovery time objective, and RPO, recovery point objective. There are 4 main types: backup and restore. Data is regularly backed up to S3 or Glacier. In case of a disaster, applications and data are restored manually. Pilot Light. A minimal version of the critical environment is always running in the DR region. Additional resources are provisioned quickly in case of a disaster. Warm Standby. A scaled-down but fully functional version of the application is always running in the DR region. It can be scaled up quickly to full capacity when needed. Multi-site active-active. Fully active workloads running in multiple regions. Traffic is distributed across regions using Route 53 and global load balancing. In any DR strategy, ensure you leverage S3 for backups, RDS multi-AZ, DynamoDB global tables, and cross-region replication for critical data.